Hey guys, Mr. Riss here to help you out with the Chapter 4 review worksheet. We're going to go ahead and go over it, see if you guys have any questions. And just, rewatch this video if you need some help. All right, so first part, we're looking at graphs here. This first graph is going to have some poles in it. And so remember, when we're looking at poles, a couple different ways we can do this. The one equation is always like f of x is equal to some number over x minus h, and h would be the number that tells us our vertical asymptote, and then plus k is the number that tells us the horizontal asymptote. So a vertical asymptote here is x minus 2, so that means we would have a vertical asymptote when x equals positive 2. So we're going to make sure we draw in our dotted line this way. All right, and then our plus k number here is plus 3. So y equals 3, so that means we'd have a horizontal asymptote. All right, now we know our graph will make some boomerangs. Actually, let's name the domain and range here. Domain, remember, is really easy. It's just really saying like x is all numbers except for x cannot equal 2, because that's where we have a vertical asymptote. And a range is all y numbers except for y cannot equal 3. Now, to figure out where our boomerangs are going to be, are they above or are they below? We have to pick numbers and plug them in. All right, so let's pick a number to the left of our vertical asymptote. I'm going to pick 1. All right, f of 1. If we plug this back into the original problem, technically, I guess that should have been g of 1, but see, that's 1 divided by 1 minus 2 plus 3. All right, that's 1 over negative 1, so that's negative 1 plus 3. All right, that is 2. So at 1, we're at 2. So you can see this dot is below our asymptote. So we're going to do our best. Let me try that again. That was really bad. Oh no, I'm kind of erased a little too much there. But we would have a boomerang that works like so. Actually, you know what? I'm not sure if you guys can see that on here. Try that again. So our boomerang would be below at the start. And then to figure out where it is on the other side, we'll pick a number bigger than 2. How about 3? We'll plug that in. What's 1 over 3 minus 2 plus 3? All right, so that's 1 over 1, which is 1, and 1 plus 3 is 4. So that means at 3, we'd be at 4, and that is above. So our boomerang would be above on the other side. All right, so that's how we deal with poles. All right, now let's talk about holes. All right, and it does give you a clue here. You need to factor it to figure out holes. All right, so the hole would be at x equals negative 3. Remember, we can find our hole from the discontinuous point of the denominator. What makes the denominator equal to 0? That'd be negative 3. So there's going to be a hole there. Now, how do we get the rest of the graph? We need to factor this out. So x squared minus 9 is x plus 3, x minus 3. Remember, it's one of those special ones. What two numbers multiply together to give us negative 9, add together to get the 0x in the middle, it'd be 3 and negative 3. And what ends up happening, we know from our division section here, is that those cancel each other out, and the graph we're going to graph is x minus 3. Okay, so this is a normal straight line. It's a y equals mx plus b line. We're going to start at negative 3 on our y, and we'll keep going. We'll make our dots. Oh, yeah, our slope is 1. 1x. And we keep going, we keep going, we keep going, keep going. We can go the other way. Now, when we get to a negative 3 on the x, we're not going to put a solid dot, we're going to put an open dot. All right, and then we'll just connect the lines. Here's the graph. All right, so you can see our domain is any number except for x cannot equal negative 3. And then our range, we do have a spot in our range. We have to look here on our graph. Where did we put that open dot? That open dot is at negative 6 on our y. So that means y cannot equal negative 6. Okay, next we got holes and poles. So we're combining these together. So what we need to do here is we need to factor this one to turn it into a separate equation. So one with a boomerang in it. Okay, so let's factor this part here. We could factor the top. Okay, actually, no, we can't factor the top. That's just x plus 1. But the bottom, What two numbers multiply together to give us 2, add together to get 3? That is 1 and 2. Okay, so that means we can rewrite this equation as, I'm going to write over here, we have a little bit more room, as 1, because if we cancel at the top, that's what's left over, and then x plus 2 plus 2. All right, so let's try to graph that as a boomerang problem, which is our a over x minus h plus k. So we would have a hole at -1. Now, the reason why we have a hole at -1 because that is one of our discontinuous points from here, but it's the one that cancels out. We would have an asymptote at -2 because that's the thing that does not cancel out. And if we look at here, that's our x minus h. So, okay, let's put our asymptote here at -2. We're going to try to figure out where our hole is later on. All right, our vertical asymptote, or horizontal asymptote, is our number being added at the end. It's +2. Okay, so we're going to have a boomerang graph. We're just going to have a boomerang graph that has a hole in it. So let's go first and try to figure out this side here. Where is our graph going to be? It's going to be above or below. What we're going to do is we're going to pick a number to the left of -2. We're going to plug it into the simplified equation. I guess we could plug it into this one as well. But let's plug it into the simplified equation. We'd get the same answer here. All right, so let's plug in -3. What's f of -3? What's 1 over -3 plus 2 and then plus 2? That's 1 over -1. So it's -1 plus 2, and that would be 1. So at -3, we're at 1. So that means our boomerang graph would be below. Now on the other side, we need to figure out where our boomerang graph is at. Well, we're going to pick a number to the right of -2. What I'm going to do is kill 2 birds with 1 stone here. I'm also going to play -1 to figure out where our hole is at. All right, so our hole here is, let's see, f of -1. We got to plug it back into the simplified equation. So it's 1 over -1 plus 2 plus 2. That'd be 1 over 1, which is 1. 1 plus 2 is 3. So that means at -1, we're at 3, and I'm going to put an open dot. So our boomerang is going to be above. We just have an open dot in the middle of that boomerang over here. And so there's the holes and poles graph. Okay. Do we got to talk about domain and range? I guess we can talk about domain and range. I'm not sure if it's listed here, but I'm just going to, let's say it. The domain, we think about x, there's actually 2 spots. We can say x cannot equal -2. We can see that from our vertical asymptote. And also x cannot equal -1 because we have our hole there. With our range, we'd say, okay, oh, not x, but y cannot equal 2 because that's where our horizontal asymptote is. And then we also say y cannot equal, where's this hole at? When we plugged in -1, it is at 3. So there's our domain and range. Okay. Next, let's simplify. We're going to just do normal fractions here. We're going to add, subtract, multiply, and divide, and just kind of mix them up. All right, so if we're multiplying fractions here, let's break them down to their primes. And we're going to just put the tops all together and then the bottoms all together. So 8 is 2 times 4, and 4 is 2 times 2. So 8 is really 2 times 2 times 2. And then 7 is just 7. Okay, so there's the top. The bottom here, 9 is 3 times 3, and 4 is 2 times 2. All right, then we see what cancels out. We definitely have some 2's cancel out, another 2 cancel out, and then we see what we're left over with. Okay, so we get the 2's cancels out. On the top, we have 2 times 7, that's 14. On the bottom, we have 3 times 3 is 9, and there's our answer, 14 over 9. It's already reduced. All right, when we're adding or subtracting fractions, we need to have a common denominator. All right, so we could go through and try to find at least common denominator. Any common denominator would work. So I'm going to multiply this one here by 4. So we'll have to multiply the top and bottom by 4. This one here, we're going to multiply by 5. All right, so 4 times 5 is 20. All right, so we got 4 times 2 is 8, minus 4 times 5 is 20. 3 times 5 is 15. All right. Then what we're going to do is we're going to add these. So we get 20 over 8 minus 5 is 7. All we have to do is just subtract the numerators now. We leave the denominators alone. Then we check to see if that can reduce. 7 is just 7. 20 is 2 times 2 times 5. Nothing cancels out. There's the answer. All right, so let's try that again with adding. We're going to have to multiply this side by 6. And we'll have to multiply that side by 7. So let's see, 6 times 7, that's 42. 6 times negative 10 is negative 60. Add to 6 times 7 is 42. 1 times 7 is 7. All right, if we add those two together, 60 plus, or negative 60 plus 7 is negative 53. I think that's it. I don't think 53 breaks down at all. I'd be surprised. All right. When we're dividing, one thing we want to do is divide by a fraction. And when we divide by a fraction, that's the same thing as multiplying by the reciprocal. All right, so that would be the same thing as multiplying by 1 over negative 3. Okay, so what we could do here is we could multiply and then we'd have to reduce later on. And you know what, let's just do that. Let's multiply this by negative 3. These numbers are small enough. We're going to multiply this side by 6. Actually, no, what am I talking about? Oh man, it's in the morning, right? 8:16. All right. What we need to do when we're multiplying, we just multiply across. 5 is 5, 1 is 1. So that's just 5 on the top. On the bottom, we have 6 is 2 times 3, and negative 3 is negative 1 times 3. Nothing cancels out. So our answer is going to be 5, and then 2 times 3 is 6, times negative 1 is negative 6, and that's negative 18. There we go. All right. So those rules don't change when we have expressions. All right, so let's see. Let's break down the 12x. So 12 is 2 times 6, and 6 is 2 times 3. So 12 is 2 times 3, 2 times 2 times 3, and x is just x. 3 is just 3, and y squared. We could put y times y, but I'm going to just put y squared. On the bottom, 2 is 2, y is y. And let's see, 24 is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. All right, so that's 24. 2 times 2 times 2 times 3, and then x cubed. Let's start canceling things out. All right, this 2 is going to cancel out that 2. This 2 is going to cancel out that 2, and this 3 is going to cancel out that 3. All right, so on the top, we definitely have a 3 on the top. That's the only thing left over on the top. Let's see, this x here is going to drop this x to an x squared. And then this y down here is going to drop that y squared to just a regular y. So we're going to see what's left over. We have a 3y left over on the top. And then on the bottom, we have a 2 times 2, which is 4, and then an x squared. All right. When we divide, we flip the fraction. So let's go through and let's just write this out here. We're going to take our 5 times our a squared plus 5a plus 6. Move my head over here. And we're going to times it by, over 3 times a squared minus 36. And we're going to times it by 6 over a plus 6. We're flipping the fraction on the right side. And then 41 over a plus 3. 1, that's a weird number. Okay, so let's see. Let's factor this out. All right, 5 is 5. All right, a squared plus 5a plus 6. We can factor that to, that is an a plus 2 and an a plus 3. What two numbers multiply together to give you 6, add together to get 5, that's 2 and 3. All right, 6 is 2 times 3, and then a plus 6 is just a plus 6. All right, on the bottom, 3 is just 3. All right, a squared minus 36, that's a difference of squares. That's an a plus 6 and an a minus 6. 41, that is weird. Why does 41 divide by anything? 41 divided by 3, no. 41 divided by 7, no. 41 divided by, no, that's 11. No, okay. So 41 is just 41. And then a plus 3. Okay, let's start seeing what cancels out. So this a plus 3 is going to cancel out that a plus 3. This 3 is going to cancel out that 3. This a plus 6 is going to cancel out this a plus 6. And is anything left over? No, we got a 2. Okay, so on the top we have a 5, we have a 2, and then we have an a plus 2. On the bottom we have a 41 and an a minus 6. And so we could distribute that out. So 5 times 2 is 10. And if we distribute the 10 on the top, that'd be 10a plus 10 times 2 is 20. On the bottom, we could distribute the 41. So we have 41a minus, what's 41 times 6? That is 246. Okay. Let's keep this going here with adding. All right, when we add, we want to get common denominator. So what we might want to do is to factor these out first. So we got 3 over 4a squared minus 25. This is actually a difference of squares. That is a 2x plus 5 and a 2x minus 5. Okay. We can take the square root of that, take the square root of that, and that's why we have a plus and minus there. All right, so what is this term missing here? This one is missing it's missing the 2x minus 5. Okay, so our common denominator is going to be our 2x plus 5 and our 2x minus 5. And we would have our 3 plus, we can distribute this part here. 2 times 2x is 4x, 2 times minus 5 is minus 10. All right, and we would just, okay, say 2x plus 5 is our denominator, 2x minus 5 is our other denominator. If we combine like terms, we have a 4x, and then our 3 and minus 10 is a negative 7. We'd want to double check to see if anything cancels out here or reduces, but it doesn't. So you can leave your answer like that, or you can put it as 4x minus 7 over. We distribute this out, we get the 4x squared minus 25. Okay, so let's check out this other one here. All right, 19 over x y squared. Okay, I think that's probably easy there. And then 7y squared over 8x squared. All right, so let's look at the denominator, see what they're missing here. This one here is missing an 8 and an x. All right, because that has an 8x squared. And this one over here is missing the y squared. All right, so our common denominator would be 8x squared y squared. And then on the top here, 8 times 19. I don't feel like doing math this morning. It's 152x minus 7y squared times y squared is 7y to the 4th. Do they have anything in common? 152, does that divide by 7? No, it doesn't. So, yeah, that's just it. Okay, now we got solving. Okay, to solve, remember, what we're trying to do is just get a common denominator, and then we only care about the numerator. The one thing we do have to look at, though, is we have to remember here are extraneous values. And so this example here, before we get started, we're just going to say, okay, x cannot equal 0. So if we end up getting 0 as an answer, we're going to say no solution, or we're going to cross it out, but we're going to see what are each denominator missing. So this one's missing a 2, this one's missing an x, and this one's missing a 2. All right, so we don't really care about the denominators. We're going to look at the numerators. We have 2 times 3, which is 6, minus 1 times x is x, and then equals 12 times 2 is 24. Okay. So if we had to solve this here, we'll do minus x is equal to, we'll minus the 6 over from 24. Let's see, that would be 18. And then we divide by negative 1. So x would equal negative 18. Since that doesn't equal 0, that's the solution. Okay. Next one here, we're going to look at the denominators. Since that's a whole number, I'm going to put it over 1. I'll make sure everything's all right. Okay, and then we don't really need to multiply by 1, but let's try to solve for x here. So there is no x on the denominator, so there's nothing we don't have to worry about, like anything there. So x can be any number potentially right now. Let's see what this would be. So this one is missing a 3. This one's missing a 4. And this last one's missing a 4 and a 3. I guess we could also say that those are missing a 1, but it doesn't really change. All right, so we'd have a 3x plus x times 4 is 4x, and then 1 times 4 times 3 is 12. All right, so we can add those together. That is a 7x would equal 12, and then divide, and we'll leave it as a fraction because it doesn't come out nice. Okay, now let's go through these ones here. So we probably want to factor first. Okay, so we got 2 over x plus 5. I'm going to leave some spaces here. Plus 3 over x minus 5. And then equals 1 over, if we factor that, you guys are probably getting used to this now. That's an x plus 5, x minus 5. All right, so let's say right off the beginning here, x cannot equal 5. Also, x cannot equal negative 5. So if we ever get those as the answer, we're going to cross those out. All right, so what's this one missing? This one is missing an x minus 5. This one's missing an x plus 5. And that one has both of them, so we don't need to do anything. So let's just look at the numerators here. We distribute this 2, we'd have a 2x minus 10. Then plus, distribute the 3 here. It's a 3x plus 15. And then the 1, we don't need to do anything with it. So we add the x's together. We got 5x, and then we'll put this together. 5, a negative 10, and a positive 15. That is a positive 5. We can minus the 5 over. That's negative 4. And we can divide, and we would get negative 4 over 5. That is not an extraneous solution, so that's good to go. All right, keeping this going, only a couple more problems to do here. All right, this next one here, let's talk about the denominator. We could say x cannot equal 10. All right. Also, we look at the denominator, they are the same. So we don't really need to multiply them by anything. They have the same thing. We're just going to set the numerators equal to each other and solve. So if 100 equals x squared, we could take the square root of 100, as long as we remember to have a plus or minus symbol there. So that means we get two answers of x equals positive 10 and x equals negative 10. Now we remember here our extraneous solution says x cannot equal 10. That'd be discontinuous. So we're going to cross off this 10 answer. Negative 10 though is still good. Alrighty, one more problem and we'll be done with this review. All right, let's look at this one here. This 5 is just a plain old 5. It's over 1. So what we need to do here is to get a common denominator. I guess we could multiply these by 1 here, but all we need to do is really multiply this by an x plus 6. An x plus 6. Let's also talk about here our discontinuous here. We got to make sure that x does not equal negative 6. All right, so let's set this up. If we distribute this 5 here, we'd have a 5x plus 30 minus, we didn't have to do anything to this one here, minus 1 is equal to, over this side here, didn't have to do anything there, so it equals 1. So 5x would equal, if we add those two together, that'd be 2. We can minus the 2 over, we get negative 1. And divide by 5, negative 1/5. Perfect timing. All right, that isn't it. So there we go. So there's the review, guys. Hopefully chapter 4 test isn't going to be too bad. And I will see you guys next time. Have a good one.